Assalamualaikum warahmatullahi wabarakatuh, and hello. We are from Group 6 and we for the machine learning project, and we will be doing a stock price prediction. So I am Arif Zakwan bin Adnan with method number 20671 and third year computer science student.
Hello, my name is Wahal Siddiqui and my metric number is 201439 and I'm computer science student at UPM. Now about our project. So this app is about how to predict the stock price using machine learning and neural network algorithms. So the stock price are like one of the most like stock trading is like one of the most difficult job to complete due to fact that there are numerous factors that affect the going stock price, which include like the volatility of the market and other dependence variable which like affect the stock price a lot. So it is very hard to predict the stock price depend on certain because there are a lot of attribute which going to affect the stock price. So our problem statement is that we will attempt to predict the stock price of Tesla based on the historic data of the stock price of the data. So Tesla is an American electric car company and it is using clean energy to manufacture electric car and energy panels, solar panel related to the like product services, and the data set from it can be obtained from this link we have added it on our problem statement. So the proposed solution is that we are going to use two machine learning algorithm. One is LSTM, which means long short term memory, and the other is random forest regression to predict this stock price. So now I'm moving to the next part, which is the data, and Arif going to describe this part.
So the data set that we get from Kaggle.com, which is the historical stock price of the Tesla Incorporated starting from its IPO on 29th of June 2010 till 17th March 2017. And it has 7 attributes, which is date, open, high, low, close, volume, and adjusted closing. So what are those actually the attributes? So date is with the date or the date lah. The opening is the opening price of when the stock exchange opens. High is the highest price of the day. Low is the lowest price of the day. Close is the closing price when the stock exchange closes. And volume is the amount of the traded stocks on that day. And finally, adjusted close is the stock's closing price when it is adjusted for the corporate actions that occurred the day before. So we only will choose to select predict the closing price of the day. So yeah, I think that's all for the start, and we move on to LSTM by Watch.
Thank you, Arif. Now, in this part, I will explain you LSTM. So, LSTM is like a network, a type of artificial intelligence recurrent neutral network which is capable of learning order of dependency in the sequence predict problem. So an LSTM network is consists of basically recurring connected block known as memories. These block can be thought of as a differentiable version of the memory chips in our digital computer. Each contain one or more recurrent memory cell called three multiplicative units. The input, output, and the forgot gate they provide continuous analogs of write, read, and reset operation for the cell. Because of this, LSTM network are suited for classification or classifying, processing, and predict the time series data. So our goal for this project was to like predict the stock price of the column by using the only column of close price based on the time series, because like our LSTM algorithm, we're going to use the historic like price of that closing column, and going to predict the value, the future predict the future value using the historic price of this column only. So first, now moving to our code. So first we will going to import all the libraries required for this project. So in our data, we got 1672 rows and 6 columns. And first in this code, what did we did? Like after importing the libraries, we are going to import our data set of Tesla and store it in a pandas data frame, so we can use it as a variable. So after importing our data, we just plot this graph using this Python code so that we could have a overview of the data. So as you can see on the y-axis, we got close price in dollars, and on the x-axis we got the date or number of the days. So on each day we can see what was the stock price. As you can see, it is too much volatile, and the price are very random. So in the data processing part, what we did, we first from our original data set, we first like filter the column of close price and store it in a separate variable. Then we change it to numpy array and store it in a variable called data set. So this data set variable is just numpy array. Then then we decided to to train for a machine learning model, we are going to train 80% of our data. So that's why we use this len function and set it to 80% only, so that later the 20% data we will use it to test our model. So 80% of data is going to train our model, and 20% data we be using for the test purpose. So moving forward, like after having this NumPy array uh, data set, so in in LSTM, they are very sensitive to the input values. So what we did, we used this function min max feature to scale our values, so that it could give us a suitable result. So this is all the function is to like scale the values. Now we got the scale value. We're going to split this scale value into two variables called train x and train y, so that we can use them to train our model. So after going through from this function, our data will going to look like this. So 0 till 30, 0 till 59 values we're going to store in this in x train variable, and the 60th value is going to store on y train. So the y train is going to contain the original value which we like get from our data set. So later we can use to like compare it with our prediction. So the y train is going to contain the original value which we like going to compare it with our predicted value when later we get out the our when we later get out our prediction from the original model. So here again, I got the two variables. Now I'm like in this part, I'm going to like reshape the values to numpy arrays. So this is in this part. we are going to set up our machine learning model for LSTM. So we just use this function, the sequential, to update the model, and to the model we going to add LSTM. And in this LSTM we are setting 64 blocks, and return sequence we like set it to true, so that our next model can get data from it and then continue to develop our model. And we set our input shape to 1 because we only have the one model. So again we are going to set up another model here, and we set our density to 32 and then to 1. And after like setting up the initial detail of the model, we are going to compile that both model into a one single using Adam optimizer. And and to prevent the loss of the data, we are going to use mean square error. So here we are just going to like compile all our models. And in the model for fit, we are going to pass our two train x and y train, so that it could set up our model. So here, as you can see, it is setting our model in the first block, second block, up to 10 blocks. So finally here in this part we are making our prediction. So we will going to like this all function is to scale our train, and then to predict our values. Sorry, this part is to for predicting the values. We are going to pass as test data in our model to predict, and then it going to scale it inverse transformation because we got the matrix output. So after like making the prediction, we are going to draw a graph which shows the closing price, which on the x-axis, and the date on the y-axis. And as you can see in the yellow are the valid are the valid prediction, and on the green part is the prediction. So we are able to predict the values. There is some difference, but as I said before, that in the stock market, it is very hard to predict, and we are using time series data. So somewhat we are able to predict the values fine. So now moving to the next topic, which is random forest, and Arif is going to explain about this.
Thank you much. So what are random forest or random forest method? So it is an assembly learning method wherein that it combines the predictions from multiple machine learning algorithms, which in this case are decision trees. So it aggregates the results from the multiple decision trees and gets a proper result, final result. So we'll move on to the coding. So it is first of all in the data processing, we will split the code into two. One is the DS, which is used to predict for the predicting attributes, and Y, which is our target. So we will use the open, high, low, and volume attributes to predict the closing price. And next, we split the data sets for training. So using a test size of zero point 0.3, which means that testing 30% of the data will be used for testing, and 70% of the data will be used for training, or a ratio of 70 to 30. So we have four data sets from it: the X train, the X test, the Y train, and the Y test. And we use the X train and the Y train to train the model, or with the on the code model.fit, to train the random forest regressor. So as we move on to prediction, first of all, we can use to check the score of the model or to get the efficiency of the model, which is at 0.99 or 99%, which is pretty good. And next, we move on to visualizing the predictions. So what we did here is that after getting the predictions, we plot it against the test results to check if the predictions are matching the test. And in this case, we get a pretty good lineup in terms of predictions against the test values, which shows that our model is doing pretty good. So that is all for the explanation videos on our project. So that is all for me. Thank you. My name is Arzakum Adnan,
Okay, thank
and
you. That's the end of our presentation.
yeah, so that is all. Thank you.